Let us discuss one more problem of probability. Let me present it through an example. In class 9 module, I set two quizzes, quiz 1 and quiz 2. I do assign some passing grades to these quizzes so that I can have an overall idea of the class. And the results were that the probability of passing this quiz came out to be 0.72, and for this quiz it came out to be 0.75. Okay, how did I get this data? See, you're aware of experimental approach to probability, no? Where experiments are conducted, more and more experiments are conducted to generalize some result. Okay, so at times the results, the probabilities are taken out by experimental approach. Okay, whatever experiment suggests, so on the basis of that we can find out the probability of those particular experiments. No? So in the same way, 40 of them were attempting the quizzes, and on the basis of the results of those 40 students, I got to know that probability of passing this quiz is 0.72 and that quiz is 0.75. Moodle gave me one more data, that probability of finding at least one of the quizzes is 0.8. At least Q1, at least of Q1 and Q2. Okay, it is 0.8. Okay, that means 80% of the 0.8 means 80% of the students were able to pass either quiz 1 or quiz 2. Now the question is, what is the probability that a person attempting these both quizzes in future will pass both the quizzes? Means, what is the probability of passing both the quizzes? Now see, here we do not have any sample space. We just have two events, passing quiz 1, passing quiz 2, and the data related to them. Okay, and we have to find out this. So here we will use some logics of probability. Okay, some axioms of probability. Axioms means the sum of probabilities cannot be greater than 1. Something means whatever logics are involved in probability are called axioms of probability. So that's why it's also called axiomatic probability, axiomatic approach to probability. Okay, now to sort out this, we must make a Venn diagram. Suppose this is quiz 1, quiz 2. So this reason is passing quiz 1, passing quiz 2. This is passing quiz 1 and 2, and the reason outside is the neither quiz 1 nor quiz 2. No, so we'll sort it out by this diagram. Okay, so let us look at it in the set form only. At least Q1 and Q2 means Q1 union Q2. No? So probability of Q1 union Q2 is 0.8. And what do we have to find out? We have to find out probability of passing both the quizzes. That means probability of Q1 intersection probability of Q2. Okay, so here let's use the set rules only to sort it out. See, we know that Q1 union Q2 means this full reason. This is actually equals to Q1 plus Q2 minus Q1 intersection Q2. No? Let me write it properly. Here it is. So So probability of this region will be equals to probability of this region minus this region. Okay, so from the same we can generalize this, which implies probability of Q1 intersection Q2 is equals to, so which is 0.8 plus 0.72 plus 0.75, which is equals to 0.67. So in this way many questions can be created. So now you have to use proper axioms, that means logics, which statement is to be connected to union, which is to be connected to intersection, which is to be connected to complement. Okay, so these can be sorted out by simple logics. Okay, all the best.